Welcome students. In this video we are going to see logical operations of 8051. That means instructions which are utilized for doing logical operations. So in 8051 we can able to perform three different logical operations using assembly language instructions. AND, OR and XOR. That means AND operation, OR operation and XOR operation can be performed using 8051 instructions. Okay. In that we are going to see AND operation now. So ANL of A comma R. This ANL represents we are going to perform AND logical operation. Okay, we are going to make logical AND operation between a value in A register and general purpose register. So simple example, ANL of A comma R1. Okay, so here what is happening means the value in R1 register and value in A register, both the values are performed with the logical AND operation. How it will be performed? Just I will show you the example. So assume that we are having A value is 33 and R1 value is 25. So as per this instruction, we need to perform logical AND between these two values. Okay, so how it will be performed? Assume, so suppose 33 is the A value. So the binary representation of 33 will be like this. Okay, 0011 0011. This is the binary representation of 33. Okay, same R1 value we are having 25. So binary representation of 25 is 00100101. This is the binary representation of 25. So as previously told, logical AND operation should be performed. What is the truth table for logical AND operation? Both the input should be true so that the output is true. Okay, if any input is false, the output is false. That is the logical AND operations truth table. Okay, so in this case, each and every bit logical AND operation will be performed. Okay, so for example, 1 ANDed with 1. So 1 and 1 means what happens as per truth table of AND operation, both the inputs are 1, so the output is 1. Okay, so in this case 1 0 1 ANDed with 0, so the output is 0. 0 ANDed with 1, so output is 0. So likewise it goes on. So the result will be this one. Okay, after performing logical AND operation between these two values, the result is this one. This result will be stored in A because A is the destination register. So the result will be stored in A register. Okay, so this is our 21, which is the binary representation of 0010 0001. Okay, this is the result. Okay, so this is how logical AND operation will be performed. So what are all the other kind of instruction which can be utilized in logical AND operation? Another one is ANL A comma direct. Only thing, this ANL will not change. Okay, this ANL represents logical AND operation, but in which two data we have to consider, so that will be changed according to the operand. Okay, so here direct in the sense a memory location which is holding the data. Okay, so direct memory location which is holding the data, so that will be mentioned here. So same, the data between these two will be considered. Okay, so logical AND operation will be performed with A and also 55, and the result will be stored in A register itself. That means 55 is not a data, it is a memory location of the data, which we have seen so many times in our previous videos. Okay, so this is what happens. Okay, same AT of RI, that means AT of R2 indirect addressing, so which we have seen so many times. I am not going to explain deep into that. So the data between A and the data between the memory location pointed by R2 will be performed. Okay, A and this data will be performed. Okay, so this is the result, and A will be acting as a destination address. That means the data result will be stored in A register. Okay, same immediate data will be included in the instruction itself. So a logical AND operation will be performed between A register and the immediate data. Okay. So another instruction is ANL of direct comma A. That means in this case, destination is a direct memory location. In arithmetical operations, what we have seen was destination and destination register will be always a register. But in logical operation, destination can be a register or it can be a direct memory location. Okay, so in this case, direct memory location value and A value will be made a logical AND operation, and the result will be stored in the direct memory location, not in A register. Okay, so because 55 is our destination, so this is possible in logical operation. Okay, so here the result is 21, that is stored in 55, not in A register. So this A register value will not change. Okay. Same thing with direct memory location value, and then immediate data will be utilized for making logical AND operation. Okay. So here this 25 is ANDed with the value stored in 55 memory location, and the result will be again stored in 55 memory location itself. Okay, this is what happens. Okay, so this is all about instructions which deals with logical AND operation. So as of now, for logical AND operation, we have seen 6 different types of instructions, how the data is processed. Okay, next we are going to see OR operation. So here also we will be having 6 different types of or logical OR operation instructions. Only difference between AND operation and OR operation is this value will change. Okay, this term will change. Okay, we will see that. Okay, logical OR operation, you have to mention ORL. Okay, all other operand position will be same as previous one. Okay, I'm just go through it. You just keep on understanding this. Okay, so this OR operation will be performed between A register value and R1 register value. Okay, so same example, assume that A register value is 33, R1 register value is 25. If we take the A values binary representation, this is what we will get: 0011 0011. R1 register values binary representation is 0010 000101. So here what we are going to do was OR logical OR operation. So what is the truth table for logical OR operation? If at least any one input is true, the output is true, right? So any one input is true and that output will be true. So 1 1 you will get 1, 1 0 also you will get 1, 0 1 also you will get 1. So 0 0 you will get 0 because there is no true condition in this case, so the output is 0. So likewise we will be having a logical OR operation. Okay, so the result will be this one. So that will be stored in A register because this is the destination register. The result by hexadecimal representation of this value is 37. Okay, so likewise we will be having all different instructions specifically for OR operation. Okay, so ORL A comma 55, we have seen ANL A comma 55, that means direct addressing. Here ORL, so no change in that. Okay, so I am not going into deep, only the difference is instead of ANL we will be putting ORL. Here also indirect addressing, instead of ANL we are keeping ORL. So another logical operation is XOR operation. So here also we will be having 6 different set of instructions. Only difference is instead of ANL or ORL, we will be putting XRL. So here if XRL is kept means that is nothing but XOR, exclusive OR operation will be performed between the source and the destination, and the result will be stored in the destination. Okay. So here same example, if we consider 33 and 25, the XOR operation will be performed. So if you take this as a binary representation, so what is XOR operation? If both the inputs are same, the output is 0. If both the inputs are different, the output is 1. Okay, so for example 1 1, both are same input, so the output is 0. 1 0, both are different inputs, so output is 1. 0 1, both are different inputs, the output is 1. 0 0, both are same input, so output is 0. Likewise it goes on. Okay, so the according to that we will have an output. So the output of final output of this operation is 16, which is 0 0 1 0 1 1 0. So this will be stored in A register. Okay, same thing with direct addressing. So that's all about logical operation instructions. We will see other instructions in next videos. Thank you.